A very good morning to all of you. I'm Harish from the Singapore Business Federation. Welcome to Mastering Cybersecurity in the Digital Supply Chain Insights and Strategies webinar jointly organized by Eclipsium, SG Tech, and SBF. Before we begin with this morning's program, we'd like to share some house rules. No recording and sharing of the content outside of this webinar is allowed unless the information is available publicly. Also, the chat function has been disabled. If you encounter any audio-visual issues, please check your connection. If necessary, you may leave and re-enter the webinar. If you have any questions, please submit them via the Q&A panel function on Microsoft Teams for our panel of speakers. Also, there will be a lucky draw conducted post-webinar. In fact, we have an exciting lineup of vouchers for wins. First prize, we have a $100 e-Capita voucher. Second prize, $50 e-Capita voucher. And consolation, we have up to 20 $10 e-Capita vouchers to be won. So do look out for the poll question link in the chat or scan the QR code to sign in with your registered name so we could identify you later. So do look out for the link that will be shared in the chat screen later. We strongly encourage you to participate in this session and also do remember to register your name, sign in with your registered name so we can identify you. Please also take note that we will be taking consent from you to share your contact with Eclipsium to reach out to you post-webinar to respond in response to the poll questions. So to kick off this morning's program, it also gives me great pleasure to welcome Mr. Ken So, SG Tech Cybersecurity Chair, to deliver the welcome address. May we invite Ken, please? Hi, Ken, over to you.
Sorry, I was muted. Yeah, thank you, Harish. Yeah, so I think first and foremost, thank you very much to Eclipsium, SBF, and SG Tech for making this sharing and learning possible. And of course, thank you everyone for joining this special session. Why I feel that this session is quite special in two perspectives. I think first is the content. I believe a lot of people have been hearing attack vectors and APT and whatnot in the cybersecurity landscape, especially in the OT landscape. I think a lot are talking about supply chain as well. I mean, not as in supply chain of goods and such, but software and digital supply chain. But the moment we talk about supply chain, digital supply chain, a lot are talking about just software, but that, in our view, is actually quite limited because there is still something called the firmware, right? Whether we're talking about IoT or OT, the firmware portion is so important, but that portion typically is not checked, even if the software is actually looked into. So today, this is a special area where we believe the expert from Encryption will be able to share more with regard to how this holistic view of protection can come in and why it is so important. So alongside the content per se, but we see also the combination of speaker here is very, very pertinent to what we are going to address because, right, we have Dalton from the provision side, I mean the service and the technology provision side, and of course Thomas from the user side, where he has been the first. We can hear firsthand from him why this thing has benefited the landscape in his field of work from a CISO, none other than a CISO, right? That is so useful and relevant. So I think without further ado, let's have this session started and now hand it over to Harris. Thank you.
Thank you, Ken, for the well-rounded welcome address. We shall now dive deeper into this morning's program with the Eclipsium. We have Dalton Tan, Senior Director, APG and Middle East, to take us through mastering cybersecurity in the digital supply chain, insights and strategies. Good morning, Dalton. Over to you.
Hey, good morning. Hey, everyone. Thanks for having me here. Let me just share my screen, and Harris, let me know if you can hear me well.
Yes, all good on our end.
And this is a presentation mode. All good. Okay. So I'm gonna take the next 20 minutes to bring you through some of the maybe some fundamentals as well as what we see in the landscape around cybersecurity for digital supply chain, and then the real meaty portion of the session today will be the panel discussion. So let's just get into it. My name is Dalton. You can find me on LinkedIn with under Eclipsium. I've been here for about 3 years, and I'm responsible for the business in APJ and the Middle East. Okay, so in the line of my work, I meet a lot of customers, and we share with them what we call digital supply chain. And a lot of times we have to deal with this question on the onset, right? What exactly is your digital supply chain? For me, a very easy way to understand is basically the entire IT stack that you use as an organization, right? From your software to your hardware, everything that you purchase or develop yourself through purchasing third-party source code, everything that you use as a technology stack, we call that our digital supply chain, right? So it can be software and it can also be the hardware. But when we look at the real definition within the digital supply chain, we are really actually looking at the software, right? And we classify it into three buckets, as you can see in this slide. We start from the right. Okay, so imagine you are an organization like a bank or a large enterprise. The first type of suppliers that you deal with in terms of your software are your in-house, third-party in-house apps. So, for example, a bank, right? They develop their own in-house third-party apps where it's like internet banking for their users. And they have in-house developers that will use open source or Linux to develop those software, right? We call this in-house software. And these third-party suppliers will supply them the Pythons, the Dockers, the MongoDBs. So that is one bucket of your digital supply chain, right? And some customers tell me it's very challenging because these developers that they have will just download or use all kinds of third-party software that has OJ, Log4j, right? So inevitably they are at risk. That's the first bucket. The second kind of supply chain, digital supply chain suppliers that you have to deal with are your third-party app suppliers. The Microsoft that you use, the Outlook, the Office, the applications that the CRM, the ERP, even these teams that you are using. Right now, there's a little bit of skepticism about how do I know whether the teams that I'm using now on my laptop is really legitimate, right? What if there's some malicious code coming in that Microsoft didn't know, right? So these are all your third-party apps that also form part of your supply chain. But the third bucket, which is what we're going to talk today, is actually the firmware or the software that comes embedded in the hardware that you purchase. Remember when you used to buy a laptop from, say, Sim Square, you go to the shop and you say, I want to make my own computer. Then I want to use this motherboard. I want to buy this chip, this memory RAM, this hard disk. And they will pass you a bunch of CDs, right? And they'll tell you that, oh, all these CDs are actually your firmware. And you have to install them and make it work, and then you have to go home and figure it out and integrate it yourself. Well, today when you buy a Dell laptop, you don't really get a bunch of CDs anymore. But that doesn't mean that there's no software in that hardware, right? The firmware is still inside there. These are all pre-installed into the laptop. The challenge here is that because you have very little control of what Dell uses or what the supplier uses, you then have a very little visibility into this software. But by definition, it is still software. So when we talk about digital supply chain, we are really talking about software. And to me, firmware is just software that is installed differently. It's basically embedded in the hardware. It, it functions no different than your in-house software or your third-party apps. Okay, so when we think digital supply chain, really is your entire software stack from your apps, third-party, in-house to your firmware. Now, why is that an implication? Because even as early as 2022, Gartner has already started to identify digital supply chain as an attack vector. And this attack vector is very unique because the adversary can attack the laptop that I'm using now at the firmware if they can come in, or they can turn back the clock and attack your suppliers. They can attack Dell or Lenovo or whichever laptop aggregator. I call them aggregators because they don't actually produce the chips inside your laptop, right? Dell buys the CPU from Intel, right? They buy the motherboard from somebody, and then maybe Asus, and Asus probably have a lot of components on that motherboard from somebody. So this has about 2 years ago, Gartner already started to identify this as a risk ever since the SolarWinds attack, right? Because now they are not playing fair. They are attacking our suppliers and our third-party suppliers or fourth-party suppliers. And why is that a problem? Because they can hide inside. If you look at your infrastructure today, and when I say infrastructure and when I say supply chain, I'm talking about the whole stack, right? The OS, the app, and the firmware, as per the 3 buckets we saw earlier. And when you ask any customer or any user, where is your risk? Where are you protecting yourself? And where are you kind of defending against the adversary? You tend to get the answer, well, I have to protect my application and my OS. That's not wrong. That's actually correct, because that's where data sit, and that's where the entire industry is very focused on. We focus on where the attackers are going. So we've been very focused on apps and OS. But little do we know that the firmware inside that hardware, which is not visible to us, is now visible to the attackers. They are going in there, either through our suppliers or by some form of way to ingest into our environment. And we see a lot of modern persistent techniques going there. This is the trouble. This is the bad news, I would say, right? Because of the vulnerabilities in the same kind of software sitting inside the hardware, they are now coming in. If they didn't come in, we wouldn't have this conversation, right? The fact is they are coming in. So when you look at your security of this supply chain, you now have quite a dynamic stack to take care of. You have your applications, right? All these OS and application that you're using, and you need to look for tools to kind of like check them or detect certain anomaly. And there's quite a lot of tools now in the market. A new generation of application supply chain security companies are out there, right? I had the privilege of speaking to some of these partners and try to work with them because they handle the stack above the OS. But within the hardware infrastructure stack, your endpoints, your servers, network, your IoT, OT, and whatnot, there's nobody really is looking at it, right? And this is our company's focus, right? It is very niche. It is not easy because that software, that firmware is embedded in the hardware, right? So this is where we are playing. Now, just to give you an idea how bad this is, or this is a little bit over the top, this video, but it's legitimate. This is a front line. There is a military personnel and he's using a drone. And unfortunately, that drone was weaponized and he nearly got killed. We did a testing earlier. Fortunately, the sound is not played, but I'm just going to play the video and you can watch as I narrate. So I can hear the sound and you can't. He's basically walking back. And if you follow my cursor on the right, there's a little drone that's flying back. If you look at your screen close enough, there's a drone flying back here, and he's landed on his hand. He's now caught the drone. Just count with me. 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds. There's a missile attack exactly almost where he was standing, and it almost got him killed. Real story. Ever since the conflict in Ukraine started, drone operators, I would say, even on both sides, more on the defender side, have been killed, right? But how did this happen? Apparently, this drone launching pad was updated with a malicious firmware, either through a phishing attack or somehow it was sent to them. They were not aware that that firmware that they were patching had a backdoor, and through that backdoor, they were able to pinpoint the guy's location, and basically the enemy was trying to kill them, right? Because these are all the guys who use drones to attack each other. And yeah, so basically that was the backdoor. But this is I'd say this is very extreme, right? However, ever since the Ukraine conflict started, the US government and a lot of nation states have realized that one of the onset of cyber war is to bring down each other's infrastructure. And one of the easiest ways to bring down someone's infrastructure is to corrupt the firmware. Because if the firmware doesn't work, the whole machine doesn't work. We start to see a lot of attacks now in the ransomware gangs also doing this kind of attack. I'll talk a bit more about that. Now, okay, so firmware can be weaponized. It can affect me. It can harm my infra, right? But isn't firmware just the BIOS, right? A lot of people that I speak to say, hey, it's not just firmware BIOS. And I thought when we are looking at our computers and all that, we are actually managing the BIOS. That's a misconception, right? Firmware is actually a simple code that allows a component to function. And all the components in a standard motherboard like this have multiple components. A standard laptop motherboard would have about 9 to 12 pieces of firmware. It's almost like you're looking at every single chip component here running its own operating system. So it's many operating system under your operating system, which is the Microsoft, right? And you can imagine the entire ecosystem below there. It's so much, right? It's just that, again, we have very little control and it wasn't ever visible to us, right? So that was the one of the other misconception that we have. And it's very complex now. Now that we know there's quite a few there, and then it becomes even more troublesome because if you look at a standard global PC manufacturer like Dell, they actually get suppliers components from different countries and many fourth party suppliers, right? So that kind of like makes the problem even harder because you can't really go to Dell because you don't know where Dell sources their components, and they don't commit because they will source based on availability. With COVID and with logistic challenges, they will just source the cheapest component from wherever they think they are getting. So here's where we are looking at. We have a innate root of trust that if I buy a Dell or I buy a laptop from the shop, it's supposed to be using components that are legit, right? That are shouldn't have that many vulnerabilities. But unfortunately, there's not something even a global PC manufacturer can control, right? Because there's so many sub components. Even more so, not only there are many components, there are many CVEs in those components, and it is a blind spot. Again, I spoke to a CISO 2 days ago, and she said, it's not that I don't want to do anything, it's that I don't have visibility. I don't even know where to start because we are looking at components here with software which are kind of like not known to us, right? So it's a big blind spot. So firmware is everywhere. It is in all components. It is a blind spot. It's like triple whammy problem. And that, if you think about it from the adversary side, it is a playground for them, right? Because they can now infiltrate or they can come in and stay extremely persistent. Now, have they? Now, the question is, have they started to do this, right? So here's some slideware to show you. Prior to 2020, you don't really see many firmware attacks in the wild. From 2020, when SolarWinds really started, we see a little bit more, maybe about 4 or 5 a year, up to 22. COVID really hit us in 22 and coming to 23. In 2023 alone, the number of attacks just on infra hardware, almost every month. Now, we have threat researchers that can give you briefing on this. This is probably not the session we'll go into everyone, but this is just to show you it's all been documented, right? A lot of hardware is getting hit because obviously firmware sits in hardware. This is 2023. 2024 just started in January. I have a whole list. The same amount just in 1 month in 24 equal to the whole year of 23, right? I've been here for 3 years and I've not seen that many new findings in a long time. This is very unprecedented, right? There's 0 days coming into almost most of those common equipment that we are using, right? So this is again troubling. Now, have the government done anything, right? I mean, this is obviously bad news, but how do we validate this data, and are we able to put some measurement on it? So one of the most important study that we are using now is this thing from CISA, this report called the known exploited vulnerabilities, right? We know that there's a lot of CVEs, common vulnerabilities out there. How many of those common vulnerabilities are actively being exploited for ransomware? And really about 700 over. And when we classify those 700 over KEVs, most of you will tell me that, I can guess that phishing will be number 1, maybe web attack will be number 2, the common attack vectors. But did you know that when you look at the data, Firmware attack vector started to emerge as early as 2015, and it has been growing exponentially. And in 2022 June, in this report, it was counted as 184. So 184 out of 748 plus KEVs was from firmware. It means that if I were to choose what to do, what toolkit to come against a victim as an adversary, firmware is definitely one of the considerations that I will use, right? Rather than maybe Office application, which has dropped a lot, maybe software libraries which have dropped, firmware is number one. And in 2023, when we updated the report, the latest one is 23, because this thing is published every June, it still continued to track very high. Many of you will be very surprised because you've been spending a lot of time trying to protect yourself on other areas that you thought maybe was an issue. But now you have a new vector of attack called firmware in hardware, right? And even when we looked at a report by Unit 42 from Palo Alto, they wrote that almost 50% of all ransomware is from software vulnerabilities. Yes, we agree. But did you know that out of all the software vulnerabilities, 2/3 of them are from hardware and not software, right? So you got Pulse Secure, Citrix, Fortinet, Sonic Walls, F5, Palo Altos. No one is spared, right? So there's vulnerability in hardware, and they are exploiting those software vulnerabilities to hide in the hardware. Pretty awakening. Now, we change a bit of gear because a lot of times we know that yes, the landscape is changing and there are now new attack vectors coming. Are there any industry regulations that will affect us? I put out a few that probably will affect Singapore pretty soon, and Asia, because it's coming down from CISA and NIST. There's been a lot of news talking about it recently, and this was the latest article on 1st of February saying that CIOs should prioritize firmware protection because it was a joint cybersecurity advisory from CISA, NSA, and FBI. Now, but if you look at the individual legislations coming out ever since 2022 SolarWinds, it has been a lot, right? It started off with the Biden administration President EO executive order, and then very shortly, financial institutions was governed by the FFIEC, published new guidance where they have to monitor and control the firmware in their hardware. Later on, we saw the defense DoD zero trust strategy, and then also the NIST CFF. So I'll pull this few out to just give you a quick summary what we saw. So yes, there were a lot of regulations from the US just in 2023 alone, but this one is, I think, one of the most important one, right? The NIST cybersecurity framework in the older one, we all understand, most of us in cyber, we know, right? The steps to cyber is identify, protect, detect, respond, and recover. These are the standard steps. We all learn that. But now, in the new 2.0, there is a new function called govern. And the govern function cuts across all other functions, and they drew it like that in the framework, right? Govern basically requires us to establish and monitor the cybersecurity risk management strategy. Now, if you look at the govern function alone, there are now 10 new controls under the GV.SCO 1 to 0 or to 10. And if you look at all of these controls, they all talk about CSCRM, the cybersecurity supply chain risk management. They expect agencies, companies to now have a process to look into their supply chain risk, which is your software, critical software, third-party software, open source, Linux and all that, as well as firmware. So it's all synonymous now. There is no longer like firmware is hardware, it's not software. No, it's all synonymous. They call all of this software, and they are equally susceptible to attacks, right? So this framework is now out. I know some auditors and companies are starting to adopt the new framework. This will affect you because there will be questionnaire requiring you to have certain controls on your firmware. And in the latest DoD Zero Trust pillar, we also have the 7 pillars now being written out. A lot of us who talk about Zero Trust we always start with identity, right? User identity, trusting that this thing is really a user. That's just one pillar in the entire zero trust framework, right? There are others. And pillar number two relates to devices. And if you read this white paper on pillar number two, it was very clear, right? Firmware was mentioned more than a dozen times, and they expect customers, when you're looking at zero trust, in order to trust this phone or this laptop that I'm using, I got to look into the firmware that they're using. I need to have a ability to monitor and know what they are selling me, right? So this is an interesting one, the zero trust pillar 2.0. So what can we do, right? It just sounds a little bit um, demoralizing that after doing so much, the adversaries have now pivoted and going to a new vector. How can we very easily get ahead of this problem, right? Now, just to put everybody on the same page, we've been out there talking about this problem for a while, and we kind of know what are some of the key problem statements that customer want to solve, right? Question you want to ask yourself is, are you just blindly trusting your device manufacturers, right? Are you buying devices with components from counterfeit or not legitimate source where there are backdoors in them, right? Do you have real visibility in your device security, right, and integrity? Meaning to say, I'm supposedly buying this laptop from this manufacturer. In transit, when their laptop is being shipped all the way to my home, has anybody tampered with it, right? Or planted something inside? Do I have a full visibility of the software bill of material on my devices? Before you want to know whether this laptop is good or not good, you must have a list of the software in them, right? And again, these software in hardware are no difference from typical open source, right? So can you check through to make sure that there's no log4j in my server, in my network, right? Do you have the capability to analyze those firmware against some kind of known good, right? How do I know whether this is really the golden image from Lenovo, right? And am I able to validate that, right? Am I able to clean it after a ransomware attack? What if a ransomware attack infected the firmware and I'm not cleaning it properly? And then I keep getting double ransomware, right? Because I thought I cleaned my machines, but actually they're still sitting in my motherboard. And is there a way to know that I've been compromised? So a lot of these questions, we can deal with them through a very easy 3-step, right? We preach inventory. Can you quickly do a quick inventory of all the SBOM in your infra? So when I look at a Dell, I no longer look at a Dell. I'm looking at the software inside the Dell components, right? Can I keep a very good inventory of that to make sure that everything is okay? Can I harden that my Dell is kind of hardened from the hardware standpoint to make sure that it cannot be easily tampered, right? And if it was tampered either through insider threat or through external attackers, can I detect that? Am I able to have real-time detection on that? Now, a lot of detection happens in the OS. We have a lot of tools that we're already using, the ELs, the endpoints, and all that. They're looking good. They're all doing what they do. But when you talk about firmware within these hardware, it is not so easy, right? You need a different class of software or tools, security tool that can help you and do exactly that, right? To help you to inventorize the hardware vulnerabilities that you may have inherited from the suppliers, and then finally detect any kind of anomaly if it was tampered with either physically by someone or remotely by some kind of injected code. So this is something that you can probably think about and look for solution that can do that, right? So bomb is something that we can do as a company, and then also finding whether you have issues. This is kind of like a bit of a repeated summary, give you some idea, right? What kind of party vulnerability in my supply chain? Do I know whether when I buy this server or machine, there's any bad code inside, implant from either nation state or bad actors, right? That even my supplier didn't know. Right? Are there such things? And if I can constantly check through this integrity, I can kind of like monitor my hardware very well, right? Continuous monitoring is something that we feel is the solution to our problem. If we can monitor that firmware against some kind of known good, then that will help. A very high level 20-minute overview, more on sharing the landscape, an idea of what supply chain is. Hopefully, I've given you a lot, quite a few things to think about, so that we can have more discussion during our panel. But let me hand over back to Haris, because I think there are some poll questions they want to ask you to take part. Thank you.
Thank you, Delton, for that insightful sharing. So at this juncture, we'd like to invite all attendees to sign in and join us at the poll. There are 2 to 3 questions over there for you, and you can stand a chance to win some exciting vouchers and prizes. So we look forward to you joining these poll questions. So we're waiting for attendees to dial in. I can see 3 attendees over here. So we still have spaces for more attendees to join in into the poll questions. Perhaps we will wait for another 1 more minute for attendees to sign in into the poll questions. Okay, and we are launching the poll now. So your first question, how confident are you in your current understanding of digital supply chain risks? You have options out there. Very confident, somewhat confident, not confident at all. And I'm not sure what digital supply chain risks are. So we hope you have gotten your answers through Delton's sharing. And moving on, we'll be moving on to the next question. Before today, were you aware of the critical role firmware plays in securing your digital supply chain? We have 3 options. Yes, I was fully aware. Second, somewhat, but I'd like to learn more. And the third, no, this is new information to me. And now we are moving on to the third question. Based on what you have learned today, how likely are you to reevaluate your digital supply chain security measures? We have 3 options over here. Very likely, I see areas we need to improve. Second, somewhat likely, I'll consider it further. And the third option, unlikely, I believe our current measures are sufficient. So we see quite a number of you on the second option, where you're looking at considering it further. So we will now move on to our panel discussion session. So that brings us to our panel discussion session, and it also gives me great pleasure to now invite Mr. Thomas Chia, who's currently the Agency Chief Information Security Officer at Nanyang Polytechnic. He leads the cybersecurity and modern workplace towers in implementing security technologies with a zero trust perspective and supporting a collaborative, modern workspace to join us in this session. To moderate the session, I would like to invite Ken again and also Delton to join us. So to attendees, if you have any questions, this is the time to raise it in the Q&A panel tab. And over to you, Ken.
Thanks, Harish. Yeah, I think this is an exciting section of this webinar, whereby we can delve deeper into understanding both from implementation practitioner point of view. I think first and foremost, let's get a little bit more insight from Dalton's presentation. Yeah, Dalton, thanks a lot for this very insightful sharing. I think you mentioned, basically from my perspective, is a well-neglected, huge blind spot of cyber vulnerability. I mean, it sort of opened up a new dimension. Listening to your speech set my heart pounding very fast, because definitely you look at the landscape, something is really amiss. I mean, it's very obvious that firmware is everywhere, right? I mean, from ICS system down to even our phone and our mouse, everywhere, right? And this is really neglected. We always look at software. So I think with that in mind, maybe you can share with us a little bit more, hence what is the actionable framework that Eclipsian actually would recommend to the customer to follow up to address these widespread vulnerabilities that is well neglected. Yeah.
Okay, so yes, thank you for the question. Yes, we get that a lot. After we talk to a customer, it looks like there's so much to do. But one of the good news I would say is that we don't have to build a wall that high yet. What we do as a company is we do have threat intelligence, and we are also tracking where the hackers are going in terms of firmware attacks. We definitely see a lot of activity at the endpoint, which is where the laptops are. Endpoints are always the low-lying fruit for the hackers, right? They're attacking the firmware at the endpoint. So we see a lot of rootkits for endpoints. We do see starting to emerge attacks on network equipment. And because network equipment, unfortunately, you can't stand any security tool on them, right? They come as a black box. You have to trust them as it is. And network equipment sometimes are never patched for many years, right? Because they're running 24/7, or maybe they are connected between the data centers, right? So customers, infra team typically don't do that. So we see a lot of activity in endpoint and network these days. And so we always encourage customer to start there. We do get customer asking us about OT, about medical IoT, but when we look at the bad guys, they are actually also not there yet, in a sense. So when you start building your firmware protection, it's very important to be mindful of matching what the adversaries are doing. So we provide a lot of threat intel to mitigate that decision. Yeah. So, but of course, there's a lot that is going to be an ongoing journey to protect our infra. Yeah.
Sure. Thanks, Dalton. I reckon it's quite a huge subject by itself as well. So, but maybe by listening to more like practitioners' point of view, I think Thomas NYP is very respectable that they are having a foresight to get this on board so quick in a way. And let's hear from him the valuable insight, how actually all this new thought and new focus actually help you to protect against all these well-neglected vulnerabilities. Yeah, Thomas.
Hi, Ken. So thanks for the question. Thanks for inviting me here as well. So I think one of the things that's lacking in this area is the visibility to these vulnerabilities in the digital supply chain, right? And as you can see from what Dalton has shared, one of the main challenges is how complex these digital supply chains are. That involves numerous components and different vendors. If you go down to the chip level, you can see the chips being designed in the US, being created, manufactured in Taiwan, Korea, and then being put together in the East Asian countries, right? So this complexity makes it even more difficult now to have that visibility and control over such a myriad of security components that you have in your network, in your servers. So I would say that Eclipsium gives us that visibility to detect. So it actually also helps us to lower our MTTD, mean time to detect, such vulnerabilities in our network, and give us that time to respond properly to such vulnerabilities. Yeah.
Sure. Thanks, Thomas. Maybe a little bit more specific will be interesting. In your journey of using encryption and also looking at more these vulnerabilities from visibility point of view, what is the topmost devices which you have experienced that given you the visibility, you were like a little bit surprised that you have these things around the landscape? Yeah.
Okay. So I think we did a POC with Eclipsium initially, right? And I think the most surprising finding that we have was I think like what Delta mentioned, that there was some firmware from our network equipment that was not being patched for a
Oh,
long
wow.
period of time. Yeah, and we do not have visibility on that, right? Except those known that that's been announced, right? And we can proactively patch it. But other than that, we found that there's some firmware that's not being patched in some different systems. We were also able to discover some shadow IT through the Eclipsium scan, and it helps us to get all this under control and have more visibility and give us the possibility to work out a plan to mitigate this in our environment. So I think uh, the most the most surprising thing was that the network equipment they weren't patched for long periods of time. Yeah.
Sure. So on this, was it a known CVE or is it unknown CVE that it was found?
I think it was a known CVE, but it was from very long ago. Yeah.
Oh, right. Okay.
Yeah.
Okay. Just now you mentioned about shadow IT. I mean,
Yeah.
as IT practitioner also, we are quite scared of this word.
Yeah.
So
Yeah.
every time you manage a environment and then people start to go haywire and start to do their own IT, quite scary. So maybe if you don't mind, I think it's very close to many audience heart. How would then the shadow IT portion relate to this firmware side that you have experienced?
So again, this shadow IT, this equipment are unknown equipment, right? They can be manufactured from anywhere in the world. It can be a China brand equipment, or I don't know, some unknown equipment that people buy from off the web, AliExpress, your Taobao, and they just plug it in for their own use. But unbeknownst to them, maybe they do not have that malicious intent, but unbeknownst to them, there could be some backdoor being implanted in these devices, right? That could compromise our security posture. So I think this is very dangerous for us, in fact, right? Yeah.
Okay, very useful. Then on a model shadow IT initiative that is initiated by all these departments, they would not know, right? I think they bring in
Yeah.
all into the infrastructure. That's quite scary. Yeah. Okay. Okay. That's good sharing. Thanks a lot. And back to Delton, I think just now you mentioned a lot of uh, ways, approaches, maybe a little bit more toward framework kind of things. Maybe you share with us how would encryption actually help enterprises to sort of comply with cybersecurity regulations and standards?
Right. Okay. So there's been a few. Obviously, US is taking the lead in a lot of these frameworks. They started off with the Biden administration had the president executive order, but they've also now broken into sectorized compliance. Right. Just naming a few. For example, in the Department of Defense, they now have this new regulation called the NDAA, which
Mm.
regulates that all agencies that purchase equipment for military use must check the firmware before they deploy them. I mentioned in the slide there was the FFIEC from
Sure.
the finance side that they require all IT equipment to have firmware controls. But underneath, they will have a bit more formal
Mm.
ones like the 800.171 that governs suppliers, or the 800-53, the risk framework. Within our system, after we look at the environment for the client, we actually map that to these compliance. But of course, the more popular ones, right? So,
Yeah.
in a very hindsight, straight away you can see, these equipment do not comply with this regulation. So,
Mm.
we can showcase that. It's in our dashboard right there for the customer to very easily meet their compliance. So we do map the compliance within our system. Yeah.
I see. I see. So Yeah, then maybe that will relate also quite close to my heart, because in the past I was in IHL as well, managing IT, and I know Poly is a stat board, and you have to comply to IM8, right?
Yeah.
So then maybe from Thomas' point of view, maybe you can share a little bit more whether it's IM8 or some regulation is beyond IM8 in a larger perspective. How would this actually help you as well?
Okay, so for us, yes, you are right. So we are set board, right? And we need to comply to IM8. But to me, IM8 is just a whole list of compliance requirements that we have from government. But on the other side, I would look at Eclipsium from a security perspective, because IM8 doesn't dictate the fact that, hey, you need to do this, implement this in your environment, get your firmware scan, or I would say rather not now, right? But sooner or later, this will come in, because NIST has this governance standard, and probably we will tailor to that. So I would say Eclipsium, I'll take Eclipsium from a security perspective, meaning that I don't see it as a compliance requirement, but I see it as a tool to enhance my security posture to dealing with these, I would say these are known unknowns, right? You know that there is a firmware vulnerability out there, but unknown to us is how do we actually mitigate this vulnerability? So this is a new journey for us. So I guess it's really instrumental for us to have Eclipsium to help us to prevent potential incidents, enhance our incident response capabilities by allowing us to patch these proactively, and then quickly trace and isolate these attempted attacks. And also by doing this, it furthers and enhances our one of our strategic goals in implementing these tools is to go from a zero trust perspective, right? So you verify everything, you trust nothing, you verify everything. So I guess this is how Eclipsium has come in. So it's not from a compliance perspective to a certain standard, but it's a security requirement to me.
Okay, very interesting perspective, because all the while in cybersecurity, we always talk about zero trust, but zero trust is a software thing. And then we talk about defense in depth, and then also the software thing. Then we talk about maybe security by design, it's also a software thing, right? So now
Yeah.
we are looking at this in a very different perspective. Wow, interesting.
Yeah.
So you're actually quite forefront in that, to really put this into practice, in my view. So now back to Delton. Yeah, it seems to, cybersecurity is a team sport. We keep running, never stop, run and run and run. And hence, how would you see Eclipsium actually help you and to sustain that pole position in the markets? A little bit more from business perspective, and also fighting the common enemy of the dark side. What are the things that you continue to refresh and bring it to the industry to help the industry?
Yeah, okay. So actually today we didn't go into any product feature set, whatever, but what we do very, very uniquely as a company is we have a patent. We patented the technology a couple of years ago. We drop sensors into machines, right? So it's very different from some customers are thinking, how do you check the machine? The machine is running 24/7, and I don't want you to come anywhere near my machine. It will cause a lot of issues. But what they didn't know is that our technology actually drops sensors onto those machines to extract out the configuration and the firmware from the machine. So it's almost like a blood test. Like you go for a blood test, you say, I just need a sample of your blood. And then after that, you can go home. You don't need to stay there or whatever. So we actually take a sample of the firmware code from all the devices in your environment, right? Actually, firmware is not a very big file. It's a very small file. We just copied it out, and then we do all the analysis out of band. We do not touch the machines after that. That blood test extraction only takes about 3 seconds. But here's where the magic happens, right? We will be able to analyze everything based on that source code. Now, with that analogy or with that principle or philosophy, well, we only need to do enough R&D to drop sensors into everything. Everything, really, from your OT to
Wow.
IT to cranes to television to your EV cars, you name it. This is the challenge for the company. We have researchers based in the US, in as well as Argentina, Europe, and now very soon in Singapore. We're going to be setting up a test lab here. And there's a constant work to do R&D on these sensors to be able to talk to different kind of machines. So yes, in order for us to be ahead of the curve, we have to pick up on the R&D, but we are also very open to work with local government and institutions to do joint R&D. Because in course of my work, when I go to a different country, there are governments and locals, they tend to use certain things that is only available in that country. Maybe it's manufactured locally or it's some classified equipment. So we do work with local companies to do joint R&D, because that joint R&D requires us to have access to the machine, right?
Okay.
So for example, I may see an agency with a very proprietary type of drone, which cannot be found anywhere else. And in order for us to build a sensor for that drone, we will need to collaborate with them, right? So something like that, we believe that the partnership with the industry will be very important. We also work very closely with OEM manufacturers. So the partnership with the ecosystem will continue to drive our R&D efforts. Yeah.
Great, great. So it's more from OEM manufacturing and kind of thing, which is down to the source of thing. Yeah, I think it make a lot of sense.
Yes, for the R&D, yes. Then once we have that code and we can build the golden image or the baseline, then we can provide the sensor technology to the end users, right? Because the end users want to be able to always constantly check that what they buy is the same as 5 years ago, right? Nothing was changed over the
Sure.
course of the deployment, right?
Yeah, I think your mention of this passive sensor is very interesting because I mean I'm also in this area where working with CI player, they are very afraid of putting things into their segment.
Yes.
Yeah, I think this passive proposition is a matter of letting them know. And our group is actually maritime, and we are into some maritime ships also. I think it's not related, but I think it's quite unfortunate yesterday, the Baltimore case. I mean, if we come to cyber, OT on the ship is a moving SCADA, and if there's a cyber attack in the ship, it's going to be even worse. Well, I'm not saying this is cyber, but it could be something like this. Yeah, so I think that's a good point. The only thing that to share with you from our practicing experience is while it can be very passive, there are always landscape and things that the OT people are still very conservative of putting things into the segment. So that portion I think is a different strategy to manage. Yeah, maybe it just takes time for people to understand the awareness of this portion going forward. Yeah. So I think that's good sharing. Maybe back to Thomas. I'm now very curious to ask you a question whereby you see with all this awareness, right? Then I think it would be very useful for everyone here to understand from a before and after perspective. So before Eclipsion, and now after you got it running in your landscape, would you be able to share with us what is the difference by way of the security posture and also your own perception of cybersecurity?
Okay, so I think before we install or run Eclipsium in our environment, I think we are pretty blind on what is actually in our environment, right? And also to keep track and govern these set of updates to these systems in our environment. So I think what Eclipsium has given us is the visibility to all these shadow IT, to all these patch status of all this equipment, the vulnerabilities that are running in our environment with regards to firmware. So it helps us to lower our mean time to detect in terms of firmware vulnerabilities and give us more time to respond to these vulnerabilities and plan ahead to mitigate some of these threats. So before Eclipsium, I think our mean time to detect was pretty long for unpatched vulnerabilities with regards to firmware. So I think Eclipse has been instrumental to help us, to enhance these kind of capabilities that we have, to proactively do our patching and quickly trace any vulnerabilities in our environment regarding firmware.
Sure, sure. So wider perspective, better peace of mind in a nutshell. Well, that's
Yeah, yeah, for
okay.
sure, for sure.
Yes. Okay. So I think in the interest of time, I think I still have one last question for Delton is, hence as a technologist, what is the roadmap? What can the market expect? Any new developments from your end?
Yeah. What supply chain?
Sorry, I think your voice is a bit muffled. We can't hear you.
Sorry, can you hear me better?
Uh,
Is it better?
Still a little
This is
bit
better.
blurry. Yeah. Okay, I think it's getting better.
Okay,
Okay.
so yeah, we're gonna grow our coverage. Even now we are being embarking on OT equipment, right? Definitely OT, definitely 5G. A lot of people are talking to us about 5G equipment, the antennas and all that, and also AI equipment. You know, AI, people
Wow.
say, is generative AI, but these AI run on sometimes very specialized hardware, right?
Sure.
Hardware that runs all this AI, and some of these hardware we are going to get some hands on them to check, right? So it's all about protecting the infra foundation of everything we build on top.
Wow. It's exciting and scary going forward in a way. Yeah. Anyway, okay, in the interest of time, maybe we can open it up for Q&A. I'm not too sure whether there's any Q&A in the chat, or I'm not expert in assessing this portion. Maybe need some help from Harish and Christine. Yeah. Is there any questions so far in the
I can. I don't see any questions at this point from the floor. So, a gentle reminder to our attendees: if you have any questions, you would also like to raise them at this point. So our panelists and Ken can also take them up.
Yes, so far I'm not too sure how to see the Q&A, but I think under the chat group, right? So
It's under the Q&A tab, where we'll
oh,
be able to see the questions. There is a question that we have just received from one of our attendees here. This relates to endpoint protection. Does endpoint protection with DLP resolve the firmware issues that were mentioned? So perhaps maybe can we hear from Dalton on this?
Sorry, can you repeat the question?
So the question relates to does endpoint protection with DLP resolve the firmware issues that were mentioned?
Uh, okay, this is a common question that we get. A lot of people they will think of EDRs, endpoint protection, to look into this. Unfortunately, they don't. We do have a video on our website or on the YouTube channel where we showed a corporate IT laptop running EDR, world-class EDR, world-class EPP. But when we and with DLP, and for those who are not savvy, what DLP does is that when you plug in the thumb drive can't work, right? You can't use the storage portion of the thumb drive. You kind of like shutting down the whole laptop, right? We have shown demos where we plugged in other peripherals like a thumb drive that can pretend to be a mouse. There are some thumb drives that are malicious. It pretends to be a mouse. And because it thinks it is a mouse, the computer will start to exchange some drivers. And in that process, the UEFI bootloader got overwritten, something like an update, right? When the UEFI is overwritten, the EDR looks at that as a firmware update. It doesn't look at that as a malicious thing. It's that update. To them, it's just an update, and they don't catch. This is not something that they catch. And of course, and nothing happens because nothing to catch. Then when you reboot the laptop, the bad firmware kicks in and the machines behave in a certain way. Even when you then load the bootloader and the OS and then the EDR, it isn't really something that they can see, right? So it's a different ring altogether, right? So this is more technical demo that we can show, but definitely it is not that they're not good. It's not the same type of threat that they are going after, right? It's just a different kind of tool. Yeah. Thanks for the question.
Any more questions? Harris, any more questions?
So there don't seem to be any questions at this point, but rest assured for attendees, if you have any further questions you would like to raise, you could also let us know post-event in our feedback. So perhaps maybe I'll hand over back to Ken in
Sure,
terms of closing the session for the panel discussion.
Sure. I'm sure we are in time. So we are in time for our wrapping up. And the wrapping up is the one-liner. I usually like to do that from the speakers because the audience are here, they spend the time. And hopefully we have one-liner wisdom from the speaker that they can go back and use them. Yeah. So maybe start from Elton. Is there any one-liner that you want to advise the audience?
Well, I guess software is everything. Firmware is also software.
Wow, good one. Wow. Okay, I'll remember that. And also, Thomas, yeah, your practitioner's point of wisdom.
So I would say that attackers are getting more and more sophisticated, and supply chain is something that we probably have minimal control over. But I would say we should always start with visibility so that it can help us to plan our action, whether be it mitigation or our roadmap forward, right, in enhancing our security posture. I would say start with visibility.
I see. So widen visibility. Sure, very good. Yeah, we can't kung fu with blindfolded eyes.
Yeah,
Sure.
sure.
Thanks. Thanks a lot. Thank you. So I think with that, I think we can wrap up the plenary and we'll hand this over to Harish. Thank you.
Once again, our warm appreciation goes out to Delton, Thomas, and also Ken for taking us through a very enriching morning. Indeed, as what Ken has mentioned, cybersecurity is a team sport, and we have seen the practical implications even in the recent incidents that's been happening around the world. So we would also appreciate at this point of time if you could also complete this feedback form where you can share with us your thoughts and also your feedback on what you're looking forward to in the future series of webinars. And also to share with you on screen, you would be able to receive a copy of the definitive guide to enterprise firmware security for in-depth insights upon completion of this feedback. So do let us know on your feedback and thoughts from this webinar. And with that, signing off is myself, Harish, and we wish you a successful transformation and stay cyber secured. Thank you.
Thank you. Yeah. Right. Stay well. All right.